Hi, this is the advanced part of the Introduction to SQL Server course. This is the fourth edition of these slides. My name is Farhad Eftekhari and I'm the teacher of this course. In these links, you can find the course material, the course slides, tutorial videos, assignments, and files. Here are some typographical conventions that I created in these slides, and you can find them at the bottom of the slides. Uh, there are some definitions for each of them. Make sure to understand them and get the best out of them when you're using the slides of this course. And here is the difficulty level indicator. The material of this course has been divided into three parts based on the difficulty level of them: easy, moderate, and hard ones. And it's based on the students that how deep they want to how deep they want to dig their material, learn and get familiar with and understand in this course. So I recommend you to at least get familiar with the easy parts and then go on and try your best to cover all of the course material of this course. And here is also a slide frameworks for these slides. Here you can find the title of the slides. Here is also the difficulty indicator. You can find the slide number here and the course of that slide. And also if you enter this code in this URL, and instead of this code use this code, you can directly be redirected to the tutorial video of that certain slide. And here is also for the content part, those icons that I described earlier, and section name and course name. And the content of this part of the slides for the advanced part are indexes, functions, store procedures, views, triggers, how to get a backup and restore a database, users and roles, getting a report from a database, color coding in query editors, SQL injection and how to avoid them, SQL performance tips, SQL security tips, and finally SQL general tips. Now let's get familiar with the first topic of this part of the course. Indexes help the database applications to find the data faster without reading and analyzing the whole table. So indexes directly affect the performance of database applications, and of course poorly designed indexes and a lack of indexes are primary sources of database application bottlenecks. And indexes are not visible to the users, so they are only for database to uh, take advantage from using them. And consider bookmarks and table of contents in a book to understand indexes. So what are indexes? Indexes are some way for a database to explore and find their specific data and rows of data that the database is looking for to find faster. And it's a question of performance, so the performance is going to be increased if you properly use indexes on your tables. Just like page numbers. Imagine you have a book and you want to search for some kind of some part of the content of the book, but there's no content part and there's no page number. So by using these contents and page numbers, it helps us to like in a fast way find the data, the pages that we are looking for in a book. So that's the whole purpose of using indexes in our tables as well. Here's also syntax and some samples by using these indexes. So for create index, here's the syntax that you have to use. You have to write create index, the index name that you're looking for, on which table, and what column name you want to be indexed. Here's also two samples. You can have a single column indexed or multiple columns indexed. And for dropping and deleting an index, you have to use this syntax, drop index, index name on that table. Actually, this part is not necessarily. So let's try by ourselves. I already created this table orders, which you can see here, the columns of this table. On this table, we have several columns. Let's wait for it in order to be loaded. All right. So we have order ID, we have user ID, product ID, and order ID, order date. So let's create one index for user ID. Let's copy paste this query here and get back here, and then new window, new query, and then window gonna pop up here. So we have this syntax here. I'm gonna name it ix orders user ID. So usually I use this kind of naming pattern for my objects, especially for indexes. So here is ix underline. So when you look at this object without opening it, you understand this is an index. And here is the table name. So you know that this index has been created for orders table, and this is the column that we are using this index for. So it's really good practice in order to apply these kind of naming rules for your objects. You don't need to open them, and you know already that what's the purpose and what does this object do. So, and here we have this table name that I'm gonna write orders, and then column name, which is user ID. So let's execute this query. And now command completed successfully. All right. Now let's open this table here, and then here on this indexes tab. Now you can see we have this index here. It's been created here. And because we had this primary key, order ID, the database itself already create an index for primary key for that table. And let's try to delete this index now. You can right click here and just select delete. But here you're not able to do that, but you can. And then use that object name here, orders underline user ID. Let's execute it. Alright, now let's mention the table name here as well. Alright, now let's refresh it. Alright, now the index is gone. So we were able to create an index for this table, and then we were able to delete it or drop it. You can also try for your own and see if you're able to create and drop an index from a database. So as I said, you have to efficiently use it. Having many indexes for the columns that you're not really looking for to sort or search or find your database on them is not really beneficial, and it's not really advised to do that. So make sure always have index for the columns that you usually use and search for. Now let's get familiar with functions, which is another advanced and very practical feature of MS SQL Server. In SQL Server, a function is a stored program that you can pass parameters into and return a value. And we have two types of functions: user-defined functions, which a user can define them and create them based on the application and purpose that the user has. And also there are many built-in functions inside of this SQL Server that you can take advantage and just use them. And here is this create function syntax. As you can see here, it looks a little bit complicated, but if you get familiar with it and use it, then it's going to be a piece of cake for you. And let's see a sample. Well, in this example, you can see we have this create function keyword here for create a object as a function, and here is the name of that function, return result, and here is the parameter that we have to pass to this function, and here is the return type of the function we selected as a varchar 50, and then here is some other keyword that we have to use. So we declare a variable at result as a varchar 50, and we check that parameter that we pass to this function. If that parameter is negative, then we set at result as negative. And if it was positive, more than equal or greater than 0, then at result will be positive. Here you don't need to add this space here. It has to be without a space. And then we return this result as an output of this function with this return at result. And then here's the way we have to end this create function syntax. And to remove a function, there are also two methods. You can use this syntax drop function, the function name, or just find your function and then right click on it and then select delete. And here are some categories of these built-in functions that you can use. Each of them contains many functions that you can just use. And here are some, well, the most common ones of functions that you can use. Most of the times you use them. Here are the list of them, and we're gonna see by ourselves that how they can work. So let's try them to see how they can work. I already created this table, added this quantity here as a small int data type here, and here is the some record of data inserted inside of this table. So I'm gonna use these functions here. Let's start with count. So I'm gonna write select count and then from my table name orders. So let's see what it does. When I execute it, it returned number 5 for me. So it means this table has 5 rows of data. Yes. So you can count the number of rows you're looking for, and you can be creative about it and like ask for, I want the orders more than, the quantity is more than 50. Let's see what will be the result for us. Greater than 50. I'm going to execute it. Only the return will be 1 because we only have 1 rows of information here that the quantity is greater than 50. Let's work with this max and min function. Let's see what is the max number for quantity here. Obviously is 100, as you can see here in this table. And let's see what's the value for min. It's 5. And if we see this table, yes, the quantity 5 here is the lowest number. And then we have average, AVG here. And when we execute it, we can see the average number of quantities here. So database will sum up this whole value and then divide it by the number of the rows and return an integer number for us. And then we have sum function, which obviously it's gonna add all of them, and then now you can see the whole quantity number is 174. And the last function, which is really practical, is this getDate function. So getDate returns the current date and time of your server, not your computer, your server. You may connect to a server and then see the time here. As you can see here, this time is different than my computer's time because I got connected to Azure database server. But if you are having your server on your computer and you install an instance of SQL Server, they're gonna be the same values for date and time. So this was the purpose of using this getDate function. There is a document in file sections that for each of these built-in function, there is a description written for them, and there is syntax to use those built-in functions. So make sure to download that file and get the best out of it. That document has been created by my previous students of this course. They nicely wrote and research about these built-in functions, so try your best to use that document. We got to this store procedures concept, which is really beneficial. So a store procedure is a group of transact SQL statements compiled into a single execution plan. Or with a simpler definition, a store procedure is an already written SQL statement that is saved in the database. Store procedures are having the ability to pass parameters to the store procedures. Instead of using the same query over and over again, you can use these store procedures on your applications or wherever you want to use them. And by using a store procedures, you're going to make their application much more secure. And here is also the syntax that you have to use in order to create an object as a store procedure object. So we have this create procedure keyword here, and then you have to mention your store procedure name. If your store procedures receive some parameters, you have to mention the parameters and the data type for them, and then you can write your SQL procedure statements here. And here is also an example for creating a store procedure. As you can see here, we have this create procedure, and then the store procedure name is sp underline location info by cdid. So I recommend you always try to have this sp underline in the name of your store procedure at the beginning of it. So by looking at this object, you know it's already, without opening it, that's the store procedure. And then this location ID, that the data type is int, is a parameter that needs to be passed to this store procedure. And then what it does is to select top one city name, state name, country name from this table, where location ID is equal to that location ID that you pass to your store procedure. So now that you got familiar with the store procedure, try to create one for yourself, for your tables or database, and to see how do they work. In SQL Server, a view represents a virtual table just like a real table. A view consists of rows with columns, and you can retrieve data from a view. The fields in the view's virtual table are the fields of one or more real tables in the database. You can use views to join two tables in your database and present the underlying data as if the data were coming from a single table. You can also use views as a security mechanism to restrict the data available to end users. And you need to know that when you to use that view, well, to hide the complexity of the underlying database schema, or customize the data and schema for a set of users, or to control access to rows and columns of data, and also to aggregate data for performance. There are purposes that we are using views. And here is also a syntax and sample to use and to create a view. As you can see here, we have this create view keyword here, your view name, and then your selected statement from this table, and if you have any conditions. And here's also an example. So we are using this join, inner join. We are linking two tables together, and then we are creating this view for this purpose. Also try to create a view for yourself and to see how they work. And if you want to change or alter a view, here's also a syntax that you have to use to alter or change or modify your view. So you just need to mention your view name and then modify that syntax, modify that statements that you created before. And to delete and drop a view, you also have to use this syntax, drop view, your view name. Here's also an example for that. Let's get introduced to triggers. We have three types of triggers in MS SQL Server: DML triggers, DDL triggers, and logon triggers. A trigger is a database object that is attached to a table. In many aspects, it's similar to store procedures. The main difference between a trigger and a store procedure is that the former is attached to a table and is only fired when an insert, update, or delete occurs. We have insert trigger as a DML trigger, update, and delete. So triggers, as I read from this slide, attached to a table, and whenever if you have this insert trigger, some row of information added to your database, then after that task, database will run that trigger for insert, or if you update some rows and you have already a trigger for update task for a certain table, that update trigger occurs. And if you have delete trigger, then after deleting a row of information on a certain table that you already defined, delete DML trigger, then that delete DML trigger will be executed. Here are also some examples for DML triggers. We have create trigger keyword here, your trigger name that you can see I start with tier underline, and then the table name, and then what kind of trigger it is, on what table, this is your table name that you have to mention, and then for insert or for update or for delete as begin. And then we have this declare variable here as a int, as a data type. Well, this part is really important. As you can see here, we are receiving that user ID value from inserted. So inserted is a row that just got added and inserted to your table. So if you have that owner ID as a column name, you can get that value just the way that I get it from like here. Select at user ID, which I already defined as an integer, and then owner ID column from that inserted row. And then you can do whatever you want with that variable here. And also for delete, everything is the same except this part that you have to mention for delete. And then here we also have deleted, that it's for that deleted row that you just deleted from your table. So we have a user ID column here. So we set the value of that user ID variable as this deleted row, and then we do whatever we want with that variable. And one thing that is different between update and then delete and insert is the way we are getting the values from that part. So as you can see here, when you are updating a row on your database, what database does is first the database deletes that row and then insert a new row with new information and updated information instead of that row. So it is not from updated. So we have one deleted row and one inserted row. So make sure to understand that and use that. And also you can create some triggers based on these examples for your tables. And then we have DDL triggers. DDL triggers, like regular triggers, fire store procedures in response to an event. However, unlike DML triggers, they do not fire in response to update, insert, or delete a statement on a table or view. Instead, they fire in response to a variety of data definition language events. These events primarily correspond to transact SQL statements that start with the keyword create, alter, and drop. Well, you have to use DDL triggers when you want to do the following. You want to prevent certain changes to your database schema. You want something to occur in the database in response to a change in your database schema, or you want to record changes or events in the database schema. So as you can see here, you create these DDL triggers that whenever you are creating an object on your database or changing, modifying, or deleting an object, you make sure that trigger fires up. And here is also an example for DDL triggers. We have create trigger, your trigger name on database for these purposes, and then After that, as you can see, a message will be shown that you must disable trigger, that trigger to drop or alter tables, and then roll back the transaction. So it doesn't allow a user to drop or modify a table. And finally, we have logon triggers. Logon triggers fire store procedures in response to a logon event. This event is raised when a user session is established with an instance of SQL Server. Logon triggers fire after the authentication phase of logging in finishes, but before the user session is actually established. There is a very beneficial ability and feature in SQL Server that with this feature you can get a backup from your database, or if you already have a backup from your database, you can restore your database from that file. Uh, and there are some type of backups, as you can see here in this table. Different type of backups that you can use, and here's a description of each type. We are looking for to get a full backup, full type of backup from a database which contains all of the information of your tables, your objects, and all of these transaction logs of your database that in a single file it's going to be stored, and later you can get you can restore your database on that earlier time. And you can have a backup manually executed for yourself, or you can put it in some kind of a schedule, daily one, weekly one, or monthly or hourly based on the need that you have. And there's a file in the document section which fully describe you how to get a backup and restore your backup database, where you can find in the file section. You can also try by yourself to see if you're able to continue follow those steps in order to get a backup. Most SQL Server databases have a number of users viewing and accessing data, which makes security a major concern for the administrator. The smart administrator will take full advantage of SQL Server security roles, which grant and deny permissions to a group of users, greatly reducing the security workload. Server roles are maintained by the database administrator and apply to the entire server, not an individual database file. The public role sets the basic default permissions for all users. Every user that's added to SQL Server is automatically assigned to the public role. So this is a very beneficial feature for SQL Server. You can have as many users as you want for your database, and you can grant them information, whether you want to grant them for some tables to have read permission, write permission, write permission, or uh, define it in a way that you want to organize it for several users, for several tables. So it's a very nice and beneficial feature for you to use when you want to increase the security of your database. And here are some roles that are already defined in the database, SQL Server database, that you can assign to a user, and by assigning these roles, that user is going to have the feature and permissions that's granted for this specific role. Here are some description for each role. And if you want to grant a role to a user, you have to execute this line of code. As you can see here, this is a store procedure, and you execute that store procedure by this command. And this is the rule name that earlier in the previous slides you encountered them, and then your username. And also, to remove users from a role, you also have to use this line of query here. So the difference is the name of this store procedure and this SP underline drop role member, and then there's this role name, and then username that you would like to remove from this role. And here's also an example for using that line of query. In this table, here are some fixed server roles that you can see, and then there are some description based on each of them. MS SQL Server, you may get reports from your database, or you can create some custom reports for yourself. There are two types of reports, standard reports and custom reports. Here are the list of standard reports that you may get from your database. There are a wide range of them, and they're really beneficial for you to use them to see the performance of your database, the size of your database, if you need to modify something to make the performance increased. And to get a standard report, you may have to right click on your database and then select reports, and then a standard reports from that list, and then find the one that you're looking for to give. So try for yourself to see if you're able to do that. Pretty simple. And here are the lists of color coding in query editors. So when you write your queries, you may see that some of the words are in another color. So this is the definition for that colors and the code of them. Make sure to understand them and understand that what words are being reserved for database, and then try to avoid using them for your object names. A SQL injection attack consists of insertion or injection of a SQL query via the input data from the client to the application. A successful SQL injection exploit can read sensitive data from the database, modify database data, insert, update, delete them, execute administration operations on the database. So there are some ways that hackers or some unauthorized users try to inject your database using these methods. We're going to explain some of them. So imagine you have some users have to enter their user ID in some text box. So instead of just writing a number, they write that number or 1 is equal to 1. And just imagine you're using this exact part and like variable or parameter here in this part of the query. So when database is reading and using this executing this line of query, here these two conditions can always be true because user ID is equal to 12 or 1 is equal to 1. So this rows of information going to be returned to the user. And here is this example also. You can see that by writing this double quotation equal double quotation, here's another way that unauthorized users can have access to database tables information. And also a batch SQL statement is this example. For instance, user writes 12 semicolon drop table users. So when database is running and executing this line of query, it's doing its job here. And this semicolon indicates the end of this line. So the next line, this line of query will drop and delete the table name users. So if that unauthorized user already know that there's a table in your database named users which contains all of this users information, by sending this line of query, it will make the database to drop and delete this users table. To protect and avoid using SQL injections, you may use parameters, and SQL parameters are values that are added to an SQL query at execution time in a controlled manner. So you make sure that the value gonna be and the parameter gonna be passed to some store procedures or functions are in some like specific data types, so users cannot just add a line of codes there. So in this way, you're gonna increase the security of your database also. And also you can configure your programming framework to disable unwanted queries. When you are having a text box, make sure what kind of information your users are entering in them. So in that way also you're increasing security of your SQL server or database. And here are also some performance tips. There are uncountable ways of creating queries with the same output and result for each task, whether there are a few of them good enough to pass the performance test to use less resources for their specific task. In the following, we discuss performance tips for making faster SQL queries. One of the tips for increasing the performance of your SQL database is to recreate tables and manipulate your data. Well, your database tables and data is like somehow like a living creature, and you need to always try to somehow find its needs and try to recreate things and like see what are the parts that are not necessarily anymore to store, or what are the parts that you need to add to your database and tables in order to make it more beneficial. So always try to mm, think about creating your tables and manipulating your data in order to increase the performance of your database. Try your best to come up with proper data types for your columns. By using proper data types, you will save so much space for creating your tables, and then you store your information there for each row by using some data types which store greater size comparing to the size that you really sufficient for you. Then for each row you're somehow overusing your resources. Here is also example that by calculation you can see based on this example what's the space that's being wasted in this case, that by using not proper data type. So it's really essential for you when you're creating your tables, use proper data type for that columns of your table. And always try to just select the columns that you really need when you want to use these selected statements. Don't say that I'm gonna bring them all and then whenever I need them I'm gonna use them. Just try to bring the ones that you really need on your back-end programming side or wherever you want to use them, and always try to write these very uh, nice written queries for your selected statements, and make sure that you're not bringing any columns that you really don't need. You can always modify your queries if you need one or two or multiple other columns for your selected statements. And try to always use index for the columns that you usually sort your data from, or search for some rows based on those column names, and try to avoid using unnecessarily indexes for the columns that you really don't usually sort or find rows based on them. So it's somehow multiple like choice for you, so you have to always try to use them in an efficient way in order to get benefits from. And try to avoid using unnecessarily joins, because when you're linking tables together, it's a very resource consuming process from your SQL server and database server. So try to come up with necessarily joins when you want to use them. And if you are all the time using this join for multiple tables, try to think that if it's possible for you to link these tables somehow together and have as some kind of a single table if it's possible. And then in that way sometimes you're just somehow avoid using this unnecessarily joins. And try to go through the architecture of your database, observe your tables, your fields. Sometimes in some situations you may somehow come up with a solution to delete some tables or some fields and columns of your tables of your database. So try to consider this fact and try to have a fresh and updated list of your tables and columns, and try to have a backup for your tables and database just in case that you made a mistake and delete a table, and then by using that backup and you can restore your tables and your data. And always try to research for new methods. So each time that these developers of major SQL applications release a new version, they put so many nice features and benefits in advanced features for your for the developers to use. So always try to update your skills, find out what's new in those applications, and try to get the best out of them by using them. And always try to use and select the proper edition of SQL Server by using something which have more features than the ones that you really need. Well, those features and services consume that you are using is sufficient enough for you. So in that way, you're gonna save so much amount of resources that you really don't need to use. And here are three steps that can increase the performance of your database. And there is a cycle. Well, if you come up with a nice database architecture, it helps a lot for the performance of your database, and writing beneficial queries also helps a lot. And then using proper edition and features of SQL Server that you really need to use is also another step that can somehow increase the performance of your database. So by using uh, efficiently all of these three steps, then you make sure you made a huge progress in increasing the performance of your database. And also here are some security tips that I would like to mention. First of all, never use default login information. Be aware of this SA username, which is a default login information to access to SQL Server, and have the users of your users created by yourself in SQL Server in order to get access to your data. And also try to use parameterized SQL statements using store procedures. In that way, you're going to increase the security of your database. And always try to use a strong password and frequently change it for your database users. And also have multiple users with different permissions for different tasks. For instance, you have some users for just reading data and some users for writing and modifying objects of your database. In that way, you're going to increase your security. And frequently back up your database uh, based on your application. You may need sometimes daily, weekly, monthly. Uh, Having this kind of backups that if something happens, then you can easily restore your data from those files. And try to always analyze and log your database for suspicious activities. Uh, Once a while, try to read them and see if there's any suspicious activities inside of these logs. And encrypt your users' critical information such as password, credit card information, and the other critical information. And at the end, try to configure Windows Firewall to allow SQL Server collections. It's an advanced topic, but if you search online, you may find so many nice articles based on them. Sometimes you can disallow some range of IPs in order to have access to your database. Sometimes you really don't need that. You may just give these permissions to your back-end programming side to have access to your database. So try your best to find some articles if you want to get to know more about these SQL security tips. And in the end, also, here are some general tips that I would like to mention. Try to have some innovative naming pattern for your objects that you can understand by just looking at your object names, what kind of object they are. For instance, if you have your tables, indexes, store procedures, views, or triggers, and having this kind of pattern for your object names, then you don't really need to open those objects to see what's the purpose of them. By just looking at their names, you can understand that. And also always try to document your progress, your queries, your code. In that way, you can also learn a lot from yourself and try to document your knowledge. And also, if you, for some reasons, lose your database files and you don't have a backup for that, you can also use your documents in order to retrieve your queries and code. As an extra subject, let's see how we can connect and work with a database in a back-end programming language. I'm going to use Visual Studio IDE and use ASP.NET C# in order to show you an example for that. So here is an application that I already created. In the web config file, which is a very essential and important file in ASP.NET projects, I define my database connection string. As you can see here, we have connection string. There is this server address, database server address that I have, and I'm using this user ID and password for this connection string. And here in this file, I'm importing some namespace that are essential in order to get connected to a MS SQL Server database and work with your data. So I'm using these two namespace, system.data and system.data SQL client. And here in this class, you can see that I'm defining a data table, data set, SQL connection, which is the name is exactly the one that I already created and defined in the web config. And here is this SQL data adapter. I created a store procedure before sp underline blog info, and I'm passing some parameter to it. Here is at entry ID parameter, and the data type is int. So I'm passing this entry ID variable for this parameter, and here you can see that I'm using and working with this SQL data adapter and filling my table as a result that I'm getting from my database. So this was an example, a simple one to see how we can work with SQL database from a backend programming language, and it was ASP.NET C# example. And in the end, also here are some links that you can visit and try to find more knowledge about these topics. I recommend you to do that if you want to gain more knowledge in this SQL Server field, and you can use internet and just search for some other advanced topics in order to gain some knowledge from. Well, this was the end of this advanced part of our course, the third and final part of our course, and we covered many topics in this part of the course. In this part of the course, we got familiar with indexes and how to create them. We got familiar with functions, different type of functions in MS SQL Server, and then we got introduced to stored procedures and got to know about views, triggers, how to get a backup and restore our backup to restore a database backup. And also we got familiar with users, roles, and how to assign roles and remove users from specific roles, and how to get a report from our database and tables. Also, we got to know about color coding in query editors, and then there were some tips about SQL injections and how to avoid them, SQL performance tips, SQL security tips, and finally SQL general tips. Here were all of the material that we had to cover in this course, and I hope you had a wonderful class.